The next topic in module 5 is satellite communication. Okay, so the satellite communication deals with the communication of the signals from the transmitter to the receiver by means of artificial satellite. Okay, so you know that the natural satellites are Earth and Moon, right? Two examples: Earth rotates around the Sun and Moon rotates around the Earth. Similar to that, the artificial satellite rotates around the Earth. Okay, so this satellite communication is mainly used for telecommunication purpose, communication to ships, vehicles, planes, handheld terminals, TV broadcasting, etc. So this figure shows the satellite which is orbiting the Earth. Okay, there are two points. One is your apogee and the other one is your perigee. That is, apogee is the point which is farthest from the center of the Earth, and perigee is the point which is nearer to the center of the Earth. Okay. So the satellite will orbit either in circular or elliptical orbits. So in this case, the orbit is elliptical in nature. So what is meant by an orbit? Orbit is a trajectory that is periodically repeated. Okay, since this is elliptical in shape, you have this as your A as your semi-major axis and B as your semi-minor axis. Okay, so this is your satellite. So the next topic is your elements of the satellite. What are the different elements you have in the satellite? So this is your structure of the different elements you have. It's starting from the user terrestrial system Earth station. It passes on to the satellite by means of your uplink and the downlink. It transmits, the satellite transmits the signal to the ground by means of your downlink. Okay, downlink, you have an antenna which comes again to the Earth station terrestrial system and the user. Okay, so here what is happening? The transmission of the signal from one of the Earth station to the satellite, and through the satellite you are getting in the receiver side. Okay, so the channel link is nothing but your satellite in this case. So what does the user consist of? The user generates the baseband signal that proceeds through the terrestrial network to the satellite at the Earth station. Okay, and what is meant by your terrestrial system or your land system, where in which the user communicates with the Earth station. That is the network which is used to communicate between the user and the Earth station. For example, the telephone switch and the dedicated link. These are the examples. Okay, and what is the next section? Next section is your Earth station. Earth station is nothing but your radio station, which is used for relaying the signals from the satellite. Okay, so the signal passes to the gets the satellite gets the signal by means of your uplink. So for uplink and downlink there are two different streams. Okay, uplink is the signal which is passed on to the satellite, and downlink is the stream spectrum which is coming with the signals which are transmitted from the satellite to the Earth station. Okay, back to the Earth station, and this is how your different elements of satellites works. And the satellite consists of large number of repeaters, relays, etc. Okay, so the next topic is your types of satellites based on the orbits. So based on the orbits, the satellites can be classified into geostationary satellite, low Earth orbit, and the medium Earth orbit satellite. Okay, so what is your first type? In the first type of geostationary, it is also called as geosynchronous orbit in practical cases. Okay, so because it is synchronous with respect to that of the Earth, you know that the satellite rotates around the Earth, Earth also rotates, right? When it rotates in the same speed as that of the Earth, so it looks like it's stationary. For example, if when we travel in a train, if another train crosses with the same speed of that of our train, we feel that we are stationary with respect to that of the other train, right? Just similar to that, here your orbit is circular in shape, and since the speed is similar to that of the Earth's speed, it looks stationary. It's called as geostationary orbit. Okay, satellite. Now the expectancy of the life time expectancy is 15 years. There are three conditions for this satellite. So it should be placed 37,786 kilometer above the surface of the Earth, that is approximately 36 kilometer. So as mentioned above, it should rotate in the same rotational speed of the earth and the same direction of the earth, that is eastward. Now next one is the inclination with respect to the earth is, should be equal to 0 because it is a circular orbit. Okay, so practically it is also called as geosynchronous orbit. So due to the gravitational pull of the sun and the moon, it shifts over a period of time, that is called as drag. Okay, shifts from the orbit, that is called as drag. And due to the centrifugal force due to the rotation of the earth and non-circular shape of the earth, it leads to the adjustment of the speed of the satellite. Always the speed of the satellite must be adjusted. That is one of the disadvantage. Okay, so the example are, it is used in TV, radio broadcast, weather forecast, backbones. It can be used as a backbones for telephone network. Okay, the next type is called as your low earth orbit. So the low Earth orbit should be placed 500 to 1500 kilometers above from the Earth's surface, and it is in the low orbit. It has a shorter period of 95 to 120 minutes. Okay, 120 minutes, and the bitrate is 2400 bits per second. So there must many satellites are required, in and around 50 to 200 because it is in the low orbit. Okay, so large number of satellites are required, high complexity. It has a lifespan of only 8 years. So it is affected by atmospheric drag and radiation, and a routing of the data packets from the satellites is required if user wants to communicate around the world. These are some of the disadvantage of your low Earth orbit. So now moving on to the medium Earth orbit, it is between your geostationary and your low Earth orbit. Okay, so it is 10,000 kilometer above the Earth's surface. So number of satellite, so what will be the number of satellites? Number of satellites will be less than your low Earth orbit and greater than that of your geostationary orbit. It moves slowly and it is simple in design. The rotation time is period is 6 hours. Some of the disadvantages are larger distance, so the delay is 70 to 80 minutes. Okay, a lot of delay is there. High transmission power and special antennas should be used for in the case of medium Earth orbit. So these are the different types of your satellites. So these are the two topics which you have to study in your satellite communication in your 5th module.